Hello, I am Seema and welcome to part 21 of the chapter Electrochemistry. In this video, I'm going to tell you about batteries. But before we discuss batteries, let us understand once again what is the difference between an electrolytic cell and an electrochemical cell. An electrolytic cell is one where electricity is used to bring about a chemical reaction. And an electrochemical cell is the opposite of this. It is a cell in which a chemical reaction is used to generate electric current. Now, we have studied about electrolytic cells in the previous two videos, and in this video we are going to start studying about batteries, which are electrochemical cells, which means cells in which a chemical reaction gives rise to electric current. So let us start our study about batteries. Batteries are of two types. They are primary batteries and secondary batteries. Primary batteries are those which once whatever chemical reaction is taking place, it does take place, and the products are formed. It results in the generation of electric current. But once the reaction takes place and the products are formed and the electricity has been produced, whatever is left behind, that is the products of the reaction, they cannot be reversed. The reaction cannot be reversed and the battery cannot be used again. You have to discard the battery. So primary batteries are those which cannot be recharged. On the other hand, secondary batteries are those which can be charged or which can be recharged. That is, once the chemical reaction takes place, it generates electric current. It is possible to carry out the opposite reaction by turning it into an electrolytic cell, by reversing the reactions by using electricity and forcing it to occur in the opposite direction to give you back the reactants, so that the next time you use it again carries out the same reaction and gives you electric current. So such batteries are said to be recharged. For example, the batteries in your phone, the battery in my camera, they can be recharged. So these are, or the battery of your car, these are examples of secondary batteries. And primary batteries would be batteries in your watch, the battery that you have, that you use in your remote controls, and the batteries that you have in clocks. These are batteries which cannot be recharged, and hence they are known as the primary batteries. So let us come to the first category, that is primary batteries. We'll be studying two types of batteries in the primary batteries. The first is Leclanche cell or the dry cell. You all are aware and you all use these cells, these little AAA batteries and AA batteries. These are the Leclanche cells. What is there in this? As you see, we've made a cross section of it, a vertical section, and you can see what is there inside the cell. On the outside, what we see is a cylinder. And the cylinder or the cup is made up of zinc. This cup, this entire body is zinc, right? And this zinc cup or zinc container or zinc cylinder, this zinc cylinder acts as the anode, right? And do you see on the two sides of this battery, there is one flat side and there is one which has a little knob on the top. The one that has a little knob on the top, that knob is actually only a cap, and that cap is of the cathode. And what is the cathode made up of? The cathode is made up of carbon rod or graphite rod, and the carbon rod forms the cathode. And since graphite is your pencil lead, if it brushes against something, it will wear and tear off. Therefore, this cap, the zinc cap, is only a protection over it. While actually the rod that is attached, the actual electrode, is a carbon electrode. Now, there is one very important thing to know about a difference between electrolytic cell and electrochemical cell or batteries. You remember in electrolysis I told you that the anode is the positive electrode, right? And the cathode is the negative electrode. Do you remember? The cathode was the negative electrode and the anode was the positive electrode. And we said this is how did we define the cathode and the anode? The cathode, I told you, is that electrode at which always it is reduction that takes place. And the anode is that electrode at which always oxidation takes place. Now, in electrolysis and a battery, that is electrochemical cell, these are two opposite processes if you really look. Because in electrolysis, we were using electric current to cause a chemical reaction. So cathode and anode were still defined as cathode was the electrode at which the reduction took place, and anode was the electrode at which oxidation took place. But the anode was positively charged and the cathode was negatively charged. But in a battery, you still have the cathode at which reduction takes place and anode at which oxidation takes place. But the reaction here is the opposite. Because here the chemical reaction is taking place and it will result in the generation of electric current. There the electrons were entering into the solution through the cathode. Here the electrons will be generated inside the cell and they will leave from the anode. But the reaction is still the same. That is, oxidation and reduction are still the same, yet the anode is the negative electrode and the cathode is the positive electrode in a battery. So the signs are different in an electrochemical cell and electrolytic cell. But cathode and anode are still defined in the same way. The cathode is that electrode at which reduction occurs and anode is that electrode at which oxidation occurs. I'm repeating this again and again because this is really important to understand and can lead to confusion if this is not clear to you. Now we understand that the zinc, that is the entire container, is the anode, and the rod in between, that is made up of carbon and which has a cap of zinc, is the cathode, and the electrolyte that is there, if you rip it open, if you rip this entire container open, you will notice that there's a semi-solid kind of a substance which acts as the electrolyte. And what is it? It is a mixture of manganese dioxide and carbon black in an ammonium chloride paste. So that is what makes the electrolyte here. Now, what are the reactions that take place at the anode and cathode? At the anode, which has zinc, now this zinc is a participating electrode. So what happens at the anode, that is the entire container, the zinc, it loses 2 electrons and forms Zn2 positive and 2 electrons are released. Now, losing electrons is oxidation. So oxidation occurs at it, and now these 2 electrons that are produced will move to the external circuit and be the cause of electric current. At the same time, what happens at the cathode? At the cathode, manganese dioxide, and that is present here in the electrolyte, ammonium ions, which are also present in the electrolyte, they gain electrons and result in the formation of MnO and ammonia. And here the oxidation state of manganese was +4 and it reduces to +3. Therefore, manganese dioxide is getting reduced here. Right? So, reduction occurs at the cathode and oxidation occurs at the anode. And this ammonia that is generated in the reaction at the cathode, it forms a complex by combining with the zinc ions. When zinc at the anode reacted to give you zinc ions, the zinc ions entered the solution. These zinc ions will combine with the ammonia and result in the formation of a complex. And this complex is the complex of zinc and ammonium ions. ZnNH3 2 positive is the complex ion that is created. The EMF of this cell is usually 1.5 volts of the Lagrange cell. Now the second kind of primary battery that we would like to understand is the Mercury cell. Now these little tablet kind of batteries that you use in your weighing machine and that are used in your watches, and these are known as the Mercury cells. These are Mercury cells in your BP machine also. So these are Mercury cells, and what do they have? If you look at this tablet and you try to make a cross section of it, you will notice again that it has a cover. And this cover is an anode. This on the top is the anode cap, and if you rip it open, you will see there are 2 layers with a separator in between. 2 layers of components. The first layer forms the anode. On top of the anode is the anode cap. Then in the middle there's a separator, and below it is the cathode. And since it is the Mercury cell, what does it have as the zinc and mercury amalgam are present and they form the anode. Zinc and mercury amalgam. Whenever you have a mixture of mercury with a metal, that it is known as the amalgam of that metal, right? So zinc and mercury amalgam, that forms the anode, and the paste of mercury oxide and carbon forms the cathode. What is the reaction at the anode? The reaction at the anode, what occurs at the anode? Oxidation occurs. So you have zinc with mercury, which is the, or what do we call it, the zinc amalgam, plus the OH negative ions. They give you Zn oxide, zinc oxide. So zinc, addition of oxygen took place. So zinc amalgam got oxidized, and therefore this is what occurs at the anode, oxidation, plus water and generation of 2 electrons. Then at the cathode, you have mercury oxide. What did you have at the cathode? Mercury oxide and carbon. So mercury oxide combines with water and gains 2 electrons and results in the formation of mercury, that is liquid mercury. That is, the mercuric ion gets reduced to mercury. So both oxidation and reduction occurred at the anode and the cathode, and the sum total of both of these reactions would be the overall reaction of the cell. And what is that? If you sum these two up, it is zinc amalgam plus mercury oxide, because if you sum these up, see what gets cancelled. You have zinc amalgam, it's not in the products. You have OH negative, 2 OH negative and 2 OH negative, they get cancelled here. Do you see this? And then what are you left with in the products? You have zinc oxide. Do you have zinc oxide in the reactants? No. You have water? Yes, we have water, so water gets cancelled out. You have 2 electrons, so the 2 electrons get cancelled out. And what is left is zinc amalgam in the reactants and mercuric oxide, right? Zinc amalgam plus mercuric oxide will give you what you have in the products now, zinc oxide and mercury, that is a liquid. So this is the overall reaction that takes place in the cell. And I did not tell you about the electrolyte that we use here. The electrolyte is a mixture of potassium hydroxide and zinc oxide. This mixture acts as the electrolyte. Now the EMF of a mercury cell is 1.35 volts. Now we understood the primary batteries, 2 types of them, that is the Leclanché cell and the mercury cell. Let us now come to the secondary batteries. We know primary batteries are those which once the reaction takes place, you have to discard the battery. It is of no use. The reaction cannot be reversed. But in a secondary battery, when the reaction takes place, the reaction can be reversed by passing electric current through it and causing the opposite reaction. And then again the battery can be reused again and again. And there is a fixed number of cycles for which a battery can be recharged. It cannot be done infinitely. Batteries also have a life. So with every reaction, a little bit of wastage is there, and there is a little bit of deterioration in the quality of the battery, until one day you find that even on recharging it does not give you enough electric current, and that is when you discard it. And that is what happens in your cars. You need to, the battery is recharged and recharged and recharged, but then it has to be replaced finally. So these secondary batteries, they can be recharged after use. The first example of a secondary battery would be a lead storage battery. Now the diagram of a lead storage battery was a little complex and my artistic skills are not very good. So I will insert a picture of the lead storage battery that I'll copy from the text and I'll put it down here. And I'll pause it here. Look at the diagram and then I'll explain it to you. Alright, so now we have the lead storage battery. It is used in automobiles, it is used in your inverters. And what does it have? It has a lead anode. The anode is made up of lead. And there is a grid of lead packed with lead oxide, lead dioxide. There is a grid. A grid means you will see have you ever been into a maze? The grid is like having pages of a book, one after the other, there are sheets of it. So you see there is a grid of lead which is packed with lead dioxide, which acts as the cathode. So you have the anode which is made up of lead and a grid of lead oxide which acts, lead packed with lead oxide which acts as the cathode. And what is the electrolytic solution in this? You have 38% of sulfuric acid solution which acts as the electrolyte. And what are the reactions that take place at the anode and the cathode? At anode you get lead combines. What is anode? Anode is that electrode at which oxidation occurs, right? And cathode is that electrode at which reduction occurs. So lead combines with sulfate ion and gives you lead sulfate, and 2 electrons are released. Because lead lost 2 electrons, it got oxidized. At the cathode, you have lead dioxide combining with sulfate ions and hydrogen from the sulfuric acid and 2 electrons, and it results in the formation of lead sulfate and water. So now what would the overall reaction be? In order to know the overall reaction, let us sum up the reactions at the cathode and the anode. And to do that, let us first cancel out what are the common things present in the reactants and the products. You have lead here in the reactants, and in the products you have lead sulfate, 2 electrons, and in the products here you have lead sulfate and water. So lead, it remains. Sulfate ions are present here in the reactant, and in the products you do not have sulfate ions, you only have lead sulfate, which is occupied, so there are no free sulfate ions. Then, if you come to the reaction in the cathode, let us see what is there in the reactants. You have lead dioxide, PbO2, and PbO2 is also not present in the products. Sulfate ion, not present in the products. Hydrogen ions, not present in the products, but you have 2 electrons which can be cancelled out. Here, you have 2 electrons in the reactants and 2 electrons in the products, so these get cancelled out, right? So now look, if you want to write down the products, what do we have in the products now? We have hydrogen and we have sulfate ions. We know that hydrogen and sulfate ions, if they are separate, they would together form hydrogen, that is sulfuric acid, H2SO4. So for one molecule of H2SO4, you need 2 hydrogen ions and 1 sulfate ion. But we have 4 hydrogen ions and 2 sulfate ions, so it results in the formation of 2 sulfuric acid molecules. Right? So the 4H positive and 2SO4, 2 negative will be written as 2H2SO4. And now let us write down what all are we left with. We are left with lead solid, we are left with sulfate, we are left with, on the reactant side, we are left with PbO2 and sulfate here. So we have on the reactant side, you have PbO2, and the H positive and 2 sulfates will form 2H2SO4. This is what we are left with on the reactant side. On the product side, you have lead sulfate is the product in both the reactions. Therefore, 2 lead sulfate molecules plus molecules of water are 2 molecules of water. And that gives you the overall reaction of this cell. That is the lead storage battery. After that, let us now come to the second kind of secondary battery, which is known as the nickel-cadmium cell. Nickel-cadmium cells are an advancement over the lead storage battery. They are more compact and they are more like they look a little bit like this, but they can be recharged like the dry cell or the Leclanché cell. So they are more practical, they are more compact, and they can be recharged even more. They have a longer battery life. So they are better quality cells. The only drawback is that the cost of their production is very high. So they are not cost effective. At places where you may need a large number of cells, using the nickel-cadmium cell might be very expensive. So these have a longer battery life, but they are expensive. The details of the nickel-cadmium cell are not there in the NCERT textbook. So all you have to know is that they have a longer life, but since they are expensive, we do not study them in too much of detail. Yet, if you just get an idea of what it is like, just like you had in a dry cell, you cut it open, and when you open it, here what did we have? In between we had a mixture of manganese dioxide, carbon black and ammonium chloride paste, which acted as the electrolyte. But in this case, we have the positive and the negative plates, which are like sheets of metal, and the separator, which separates the 2 sheets. So the positive plate, separator, and the negative plate. The plates or the electrodes are separated like this. And the overall reaction that takes place in the case of a nickel-cadmium cell is the cadmium reacts with nickel hydroxide, gives you cadmium oxide and nickel hydroxide and water. This is the overall reaction which is available for the nickel cadmium cell. So with this, I'll finish batteries. In the next video, I'm going to talk about fuel cells, and then we'll talk about corrosion, and that will be the end of the chapter. So if you found this video helpful, give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.